All right, so like we saw for the cyclobutane, the cyclohexanes can also do a ring flip. And when they do this, some interesting things occur. So let's go ahead and draw a cyclohexane. And then we can draw some substituents on it. We'll say that A is up here axial, and then I'll just put kind of maybe B down here being equatorial. And then we'll also have kind of C over here being equatorial, and then D being axial. And so let's see what happens when it ring flips. And so this is going to be pretty hard to see on a piece of paper. What I would recommend is to go ahead and Google cyclohexane. Ring flip, and then take a look at some of the YouTube videos, or if you have a model yourself, go ahead and take a look at these. But this is the way we're going to demonstrate these ring flips, and the way that pretty much everyone demonstrates these ring flips. So you can see that our two parallel lines went kind of this way. We're going to flip them and go the opposite direction. All right, and so we can see that occurred. And so what happens during this ring flip is that this back carbon actually comes forward, and then this front carbon actually goes backwards. And at the same time, these axial and equatorial positions switch. And so this carbon back here is now this carbon up here, and this axial A now becomes an equatorial A. And the equatorial B becomes the axial B. And then this carbon over here now becomes this carbon over here, and the equatorial C now becomes an axial C, and the axial D becomes an equatorial D. And so again, this is somewhat hard to see on these pieces of paper, but if you take a look at some of these videos and these models, they do work. And then when they ring flip back, you'll just do the reverse of this process. This is also shown in this energy coordinate diagram. So you can see on these lower energy sides, we have our two ring flipped chairs, and then this demonstrates how they ring flip, right? So this carbon right here is going to go up, and then becomes this carbon right here in this half chair formation. And then when it continues to go up, you get this boat conformer. And in this boat conformer, you have these two big carbons, these two big groups right next to each other. And so this causes a lot of steric strain. And so this is why this boat conformer is not preferred. And then this carbon over here starts going down, goes further down, and then becomes this carbon right here. So let me label that a little bit better. So we have this carbon here, becomes this guy, becomes this guy, becomes this guy, becomes that guy, and then vice versa. This carbon over here came from over here, came from over here, came from over here, came from over here. Again, this is pretty difficult to see on these two-dimensional pieces of paper. You want to go ahead and Google some videos or play along with your model kit to truly understand this.